So we are finally into the easier stuff. At least it's easier. It's quicker if you know what you're doing. It's not near as long division or even synthetic division. It's quicker. This is factor completely ends. Well, these are factored completely. They're not actually equal to 0. I wish it was, because this one's doable. Let's go ahead and solve that one too. So 49, let's make it factor completely and solve, because it's solvable. Even if you don't know anything yet, it's still solvable. There's a couple ways of teaching this. Some teachers teach this using what's called the U method of substitution, which I actually like, but man, it just messes with kids' minds. I'm actually a bigger fan of brute force factoring. Now, what you have to know is you have to be good with your exponential rules. You have to understand that x to the n times x to the n is x to the 2n. Whoops, I wrote that wrong. Is x to the 2n, because we add exponents. All right? So to create an x to the 2n, I need to lead my binomials with x to the n's. From there, it's actually really easy. To make a positive 1 and add to negative 2, I need to be negative 1 and negative 1. And since I'm solving this one, I get to use the zero product property. Actually, I can't actually solve this one. I have no idea what x is. Sorry, just factor. That's how it factors. Factors is x to the n minus 1 and x to the n minus 1. The reason I went back to erasing that is because it has two variables. Can't solve with two variables. Oh, that's the second equation. 48 is probably factoring by grouping. It looks like factoring by grouping to me. We have 7a squared plus bc squared. And what I notice is that both of these terms contain a c squared. And I can pull out, if I pull out a c squared from 7a c squared, I have a 7a. If I pull it from bc squared, I have a b. Now the nice thing about the factoring by grouping technique is that this factor has to repeat. So I can look at the second set and think, what do I have to pull out so that I end up with positive 7a plus b? I have to pull out a negative d squared. Hopefully you can see that. Negative d squared times 7a is negative 7ad squared. Negative d squared times b is negative bd squared. The common factor here is going to be 7a plus b. And the stuff left over is c squared minus d squared. But you're not done. You see that word completely? So most of you doing the homework are familiar with the a squared minus b squared pattern. Factors is a minus b times a plus b. So now I'm saying 7a plus b times c minus d times c plus d. And that is the complete factorization of the original polynomial. Ta-da! 47 is up next. 47 is also a factor by grouping. It is also a solve. It's the same technique as I did in 48. Cover up a pair, pull what you can pull. You can pull a z to the fourth. You'll be left with z minus 3. 9 out of 10 times, if you see a negative, pull it. I can pull a negative 16. It leaves me with z minus 3. Notice those factors match. Z minus 3 is the common factor. Z to the fourth minus 16 is the stuff left over. Z to the fourth minus 16 is a difference of two squares. Factors is z squared minus 4 and z squared plus 4, still equal to 0. Z squared minus 4 factors is z minus 2 and z plus 2. And z squared plus 4 does not factor. Z squared plus 4 is going to be something I work on off to the side. One of my z values is 3, one of them is 2, one of them is negative 2. And this bad boy's got to be worked with. Z squared plus 4 is nothing. Z squared is negative 4. Square root, z is plus or minus twice I. So 5 solutions. No surprise, z to the fifth would have 5 solutions. That one actually has 5 distinct solutions. I'm going to pull a 32x because I can. So 32x to the fourth minus 4 is 0. Gonna factor because I can. Gonna rewrite these equal to 0 because I can. So if x squared is 2, x is plus or minus root 2. This one is going to be imaginary. It's going to be plus or minus I root 2. So there's 4 distinct solutions. Then there's that big one up top, 32x equals 0, which means that my x is 0. 5 answers for x to the fifth. Fundamental theorem of algebra. 45. 45 looks to me like everything's divisible by something, probably a 3. Seems like it's 3. And an x. What is it? 3 times what? 24 is 72? 36. So there's that. Assuming I did everything correctly. I feel like I did. Thank the heavens, there's only one way to make a 5x to the fourth. Takes a 5x squared and x squared. Factors 36 that are jumping into my head are 9 and 4. And that's the correct pairing too, I think. Or is it? No. How about 12 and 3? 2 and 18. Have I done everything correctly? I bet there's a sign mistake on this one. Nine and 4 won't work. What else we got? 12 and 3. 12 and 3 don't work. We got 13. No, we don't. Got 2 and 18. Man, that stinks. I'll pause this real quick so you guys don't just see me staring at the screen. Be right back. I might change the problem. Alright, so what did I just learn? That you get to omit 45 because this does not factor. Does not factor. So, 45 is done. You get a freebie. 44. That really bothers me. It really bothers me. But anyways, this one should. 3s to the fourth minus s squared minus 24 takes a 3s squared and what? An s squared to create 3s to the fourth. Factors 24 are probably going to be 4 and 6. No, 8 and 3. 8 and 3 is the pair. Because the outside makes 9 and the inside makes 8. If the 9 is negative and the 8 is positive, we're in business. It says all solutions. So s squared minus 3 is 0. S squared is 3. So s is plus or minus, because you love them pandas, the root of 3. 3s squared plus 8 is 0. 3s squared is a negative 8. S squared is negative 8 over 3. This is where this one gets ugly. S is plus or minus the imaginary root of 8 over the root of 3. And I wish it was easier than this. I know that you know how to simplify the root of 8, plus or minus 2i root 2, but you have to clean up that root 3. And you do that by multiplying the top and bottom by root 3. So you get s is plus or minus 2i root 6, both pieces plus or the minus sitting over a 3. So there's 44. 43. 43 is easy to factor, at least initially. Its initial factorization, since it's an a squared minus a b squared pattern, is x squared minus 5 times x squared plus 5. That's equal to 0. Now, if you're really smart, you can realize that 5 is actually the root of 5 squared. That's x minus root 5 and x plus root 5. If you're really, really smart, you can realize that to create x squared plus 5, that it is x plus I root 5 and x minus I root 5. I don't think anybody teaches kids how to factor like that, and I'm not actually encouraging it. I'm just showing you it can be factored. If you didn't get that, it's fine. You can go off the side and you can say x squared minus 5 is 0, x squared is 5, and by God, x is plus or minus root 5. If you didn't get the second one, then you go off to the side, x squared plus 5 is 0, x squared is negative 5, and by God, x is plus or minus the imaginary root of 5. But anyways, your x values are root 5, negative root 5, negative I root 5, positive I root 5. 4 of them. 42, 125n cubed plus 216. This is probably a sum of two cubes pattern. This is probably a cubed plus b cubed, which is equal to a plus b times a squared minus ab plus b squared. Where do we come up with these numbers? That's a good question. I know that if I take a 5 and cube it, I get 125 n cubed. What's the other one here? 216. It's not 4. It's 6. So my A is 5n, and my B is 6. If I square a 5n, I get 25n squared. I take away the product of 5 and 6, which is 30n, and then I square the 6 and get 36. There's an easy solution right here. It's n is negative 6/5. You got to do the QF here. So you got to drop down and do opposite b, plus or minus square root of b squared minus 4 times a, which is 25, times c, which is 36. All sitting pretty over twice a 25, which is 50 and 50. And those numbers are going to be freaking huge. They're also going to be imaginary. Every time, whenever you're doing the sum of two cubes or the difference of two cubes pattern, the larger set of parentheses is imaginary. So inside that radical is negative 2700. I'm kind of glad that's what it is. I know that's divisible by 900. The root of 900, if my brain's working right, is 30. So it's going to be 30I root 3. Where was I? I was at 30 over 50, right here, which is 3/5, plus or minus 30I root 3 over 50. There's that 30 over 50 again. So x is 3/5 plus or minus 3I root 3 over 5. And this would be my 6th period coming in, which means I'm done recording for now. Another